Welcome back to the Deep Dive. Today, we are getting into a topic that's moves from this quiet scientific question to a really urgent public health conversation.
It really has.
We're talking about the long-term systemic health consequences of chronic cannabis use. With legalization just sweeping across the map, more and more people are using it regularly, often for years.
Right, and the focus is usually on, the lungs or maybe mental health.
Oh, exactly.
Yeah.
But our mission today is to understand what this is actually doing to your vascular system, your heart, your arteries, the whole network.
And it's an absolutely essential deep dive. Here's why. For decades, the research has been, tainted by one major confounder,
Tobacco
smoke. Most people who smoked cannabis also smoked cigarettes, which made it almost impossible to figure out what damage came from the cannabis compounds themselves. The medical community has been desperate for clean data on THC specifically.
So that's what we have. We're going deep on one source today. The CANDIDE study, which stands for cannabis. Does it damage endothelium?
A great acronym.
It is. And this study was designed specifically to cut through that noise, to separate chronic cannabis and THC use from tobacco, to really pinpoint the vascular risks.
Precisely. The core objective was to see if there's a link between chronic cannabis use in its different forms and vascular endothelial dysfunction.
Okay, so endothelium. For you, the listener, if there's one technical concept to really grab onto today, it's this one.
It really is. The endothelium is this specialized single layer of cells. It lines the inside of every single blood vessel in your body and your heart. And it's not just a passive coating.
It's active.
It's very active. It's managing blood pressure, clotting, inflammation, vessel relaxation. I mean, if your endothelium is damaged, that is the earliest sign of cardiovascular trouble. It paves the way for heart disease, for stroke.
Okay, so leap and pack the methodology here, because I think the design of this study is what makes these results so powerful. They went to great lengths to get a clean sample.
They absolutely did. So it's what's called a cross-sectional study. They're taking a snapshot of different groups at one single point in time.
And who are they looking at?
They recruited age-matched, healthy adults, all between 18 and 50 years old, from the San Francisco Bay Area over about a 3-year period.
And here's the detail that separates this study from, decades of older literature. The exclusion criteria.
Ironclad. To even be in the study, you could not smoke tobacco, you could not vape, and you couldn't have frequent exposure to secondhand smoke.
So that's the crucial isolation right there.
That's it. We are looking purely at the effect of chronic exposure to THC or the non-tobacco combustion from smoking marijuana.
So they end up with 3 really meticulously defined groups. Tell us about the cohorts they were comparing.
Okay, first, you have the chronic marijuana smokers. Second, the chronic THC edible users. And third, you have the non-users, who act as that healthy baseline, that control group.
And they compared these 3 groups using a few key measurements. Let's get into those tools, because they were designed to assess function right down to the cellular level. What was the main one?
The main one, sort of the gold standard for function, is flow-mediated dilation, or FMD. FMD. Think of your artery walls like flexible rubber hoses. When your body needs more blood flow, like when you start exercising, they have to relax and get wider fast. FMD measures that exact ability.
So a high FMD percentage means your arteries are flexible, healthy.
Exactly. A low FMD means they're stiffening up, they're struggling to relax, which is a major early-stage cardiovascular warning sign.
They also looked at a measure of actual structural stiffness,
Yeah.
right? Not just function.
They did, using pulse wave velocity, specifically from the carotid artery in the neck to the femoral artery in the groin.
So PWV.
PWV. Well, FMD looks at that moment-to-moment flexibility. PWV assesses the underlying stiffness of the pipe, so to speak. If your pulse wave travels really quickly down that path, it means your arteries are rigid. It's an important, but often later-stage indicator of disease.
And then, this is the really fascinating part, the cellular experiment to get at the how, the mechanism. They didn't just measure the outcome. They used blood samples to see what was happening underneath.
This is where we peer under the hood. They used human umbilical vein endothelial cells, HUVECs, we call them. They're a very common, reliable model for studying the lining of blood vessels.
And they exposed these cells to what?
To the blood serum of the participants from all 3 groups, and they were looking specifically at the effect on nitric oxide production.
Okay, so what's the connection there? Nitric oxide and FMD.
Nitric oxide, or NO, is the body's natural relaxing agent for your blood vessels. You can think of it like the biological WD-40 for your arteries.
I like that.
When your body needs your vessels to dilate, the endothelium sends out this big signal of NO. So impaired NO production directly leads to impaired FMD.
And they looked at a specific kind of NO production.
They did. They focused on VEGF-stimulated NO production. VEGF is basically the trigger, the call to action for the endothelium to produce that vital nitric oxide. If that system is broken, the vessel just stays stiff.
Okay, we have the cohorts, we have the precise measurements. Now, here's where it gets really compelling. Let's look straight at that FMD data, that crucial measure of arterial flexibility. The study tracked 55 participants in total, mean age of just over 31.
Right, and we have to start with the baseline, the non-users. A healthy person in this age group should have really flexible arteries. Their mean FMD was 10.4%. That's our healthy benchmark.
10.4. Okay, now let's compare that to the chronic users. We know inhaling smoke, any smoke, introduces combustion byproducts. What did they find for the chronic marijuana smokers?
Well, their mean FMD dropped a lot. It fell to 6.0%.
Wow.
That is a really significant decrease in flexibility. It suggests real impairment of that endothelial function. And the statistics back it up. That result is not random.
A 4.4 percentage point drop is worrying. But wait, this is where the conversation for me just turns on its head. The whole idea for many people is to avoid smoke by switching to edibles, right? Protect the lungs.
It's a logical assumption.
So what FMD value do they find for the chronic THC edible users?
This is the first headline finding you really need to remember. The chronic edible users had an even lower mean FMD, 4.6%.
Wait, hold on a second. We're talking about people who are ingesting THC, they're avoiding all combustion, and their arterial flexibility is measurably worse than the smokers.
Worse than the smokers, dropping from that healthy 10.4% all the way down to 4.6%.
Were the researchers as surprised by this as I am?
I think everyone was. It's a profound result. When medical professionals see FMD values down around 6% or 4.6%, those are figures we typically associate with individuals who have serious chronic risk factors.
Like much older people or...
People decades older, or those with uncontrolled hypertension, high cholesterol, or people who smoke tobacco habitually. The implication here is staggering. Chronic, high-frequency exposure to THC, even without any combustion, is associated with vascular damage that mimics or even slightly exceeds the impairment we see in chronic smokers.
And this wasn't just some random low score, right?
Right.
The data showed a clear relationship.
That's what makes it so convincing. They found a strong dose-dependent relationship. For the smokers, the more often they smoked, the lower their FMD was. A really strong correlation.
And for the edible users.
Crucially, the same thing. The greater the total amount of THC they ingested, the lower their FMD was. Again, a significant correlation. This isn't an accident. It's a systemic effect that's directly linked to the level of chronic exposure.
Okay, so we've established the what. Chronic use, whether you smoke it or eat it, is linked to this dramatic drop in the flexibility of your arteries. Now we have to talk about the how.
The mechanism.
Right. If both groups show similar damage, is the body breaking down in the same way? That brings us back to that cellular experiment and the nitric oxide.
This is, I think, the most important nuance of the whole study, because it tells us that avoiding smoke doesn't mean you avoid the damage. It just changes the mechanism of injury.
So let's start with the baseline again. The healthy non-user group, what was their nitric oxide level?
Their mean NO level was 1.5 nanomoles per liter. That's our healthy production line.
And when they exposed the test cells to the serum from the chronic marijuana smoker group?
The WD-40 production line was definitely impaired. VEGF-stimulated nitric oxide levels were significantly lower. They dropped to 1.1.
Okay, so that suggests the combustion products, or something related to smoking, is actively damaging the cell's ability to make that relaxing agent.
Exactly. So for smokers, the cause and effect chain seems clear. Less nitric oxide leads to less FMD. The arteries get stiff.
That makes perfect sense. It's consistent with what we know about smoke and toxins.
Yeah.
But if the edible users had the lowest FMD, the stiffest arteries, you would expect them to have the worst damage to the nitric oxide pathway.
You'd think so. That's the logical leap.
So what did their serum show?
And this is the crucial divergence. The serum from the THC edible users group showed no significant difference in nitric oxide levels compared to the non-users.
None at all.
Their mean NO level was still 1.5, the same as the healthy controls. Their nitric oxide production pathway was seemingly completely intact.
So the end result is the same. Stiff arteries for both groups. But the cellular mechanism is totally different.
Totally different.
The smokers have stiff arteries because their ability to produce the relaxing agent, the NO, is broken.
Correct.
But the edible users have equally stiff or even stiffer arteries. But their NO pathway is working just fine.
Exactly. And that is the synthesis of the findings. Chronic cannabis smoking and chronic THC ingestion both seem to be associated with this endothelial dysfunction, but they get to that destination through totally distinct mechanisms.
So the smokers are likely suffering from the inflammatory stress of combustion.
Right, even without tobacco. But the edible users are experiencing a systemic effect of chronic THC exposure that is clearly damaging their FMD through a completely different and right now completely unknown pathway.
That is a critical finding for future research and for you, the listener, trying to assess risk. But let's just tie up that PWV measurement before we conclude because it adds some important context.
Yeah.
If the FMD was so poor, suggesting this stiffening process, why didn't the pulse wave velocity, the measure of structural stiffness, also change?
That's an excellent point. And the study found that PWV and some other vascular properties showed no significant difference between any of the groups.
Why not?
It's likely because FMD failure, that functional damage, is a very early warning sign. The structural changes, the kind measured by PWV where the arteries become permanently rigid, that takes years, often decades, to fully develop.
Ah, so they caught it early.
They caught it early. Since the mean age of these participants was only 31 and they were generally healthy otherwise, the study likely captured the initial functional impairment before it became severe, irreversible structural damage. It confirms the damage is immediate and physiological.
So what does this all boil down to for the listener who's trying to navigate all of this?
The big conclusion really is unambiguous. Chronic use of cannabis, whether you smoke it or you ingest it as an edible, is associated with significant endothelial dysfunction. And it's similar in severity to what we observe in chronic tobacco smokers.
So for you, the listener, this means we have to broaden our understanding of risk.
Completely. Switching to edibles might protect your lungs, but based on these FMD results, it does not appear to negate the serious risk to your cardiovascular system if you are a chronic user. The risk is systemic, it's not just respiratory.
That reframes the entire conversation around cannabis safety. So to recap, the FMD, that flexibility measure, drops significantly in both chronic smokers and chronic edible users.
Right.
But only the smokers showed that clear negative effect on the specific nitric oxide pathway.
Which emphasizes that the THC molecule itself, or its metabolites, is doing something profound to the vascular system when it's chronically present, even when you take combustion completely out of the equation.
And this leaves us with a final and I think really provocative thought that the scientific community now has to aggressively pursue.
It's the next big question.
Given that the vascular dysfunction in these chronic edible users is so dramatic, similar to the damage in heavy smokers, but the mechanism for that group is completely different. Their nitric oxide was normal. What other non-NO-related chemical compounds or biological interactions are driving that severe arterial impairment?
Yeah.
What is the hidden mechanism of damage that chronic ingestion activates? That is the next great question this research has unveiled.
It forces us to look beyond the obvious pathways and dive into the deeper molecular biology of THC's systemic effects.
A truly crucial deep dive. Thank you for joining us. We'll see you next time.